All right, we get to end the semester with the equation of a line. Isn't that great? By the way, we have. I know you're thinking again. Well, we have some review activities next week. We have like tomorrow. I have some things to clean up. We've got to do some more stuff with the challenge problems. We've got an IB problem and a test next week, and then we got to like talk about reviewing for the culminating activity as well. So,
what? Yeah, same.
That's what we're calling it. Culminating assessment of some kind. We're gonna look at somebody assessment. It's not a semester exam. It's a culminating activity. Next week. I think that is actually what your calendar says too. You can look at it. All right. Are you excited to learn another equation form of the equation of a line? Are you excited? You already know a couple. You might think, I thought I was done with lines back in Algebra 1. But no. I know you know some different forms of the equation of a line, like point slope form and slope intercept form and standard form perhaps, and maybe you know another one, I don't know. But we're going to give you one more today. It's not for Algebra 1 students. This is for grown-ups. Okay? And the reason is because of the constants with which we use to define this line. They're trig flavored constants, not appropriate for Algebra 1 students. Okay. Do you recognize in the past that we've been able to define a line uniquely by using like a couple different parameters? Sometimes it's the slope and the y-intercept, or sometimes it's a point and the slope. Sometimes it's 3 letters, A, B, and C. But once you've determined what those things are, then like you've uniquely determined the line that we're talking about. Well, the same thing is true of these 2 letters. Okay, P and the Greek letter phi. We always like to use Greek letters for angles, isn't it? And I'll call that phi. And the reason I'll call that phi is because aside here, we're going to have a little aside. Some people call that Greek letter phi. I prefer to call it phi. And the reason is because if you call it phi, consistency would demand that you call pi p. And we don't call pi p. We've all agreed to that, I think. So phi must be what we call this, okay? Is that okay? Phi, pi. It makes sense. But you'll hear people call it p too. Just make sure you understand we're all talking about the same thing. All right, it's not clear what I'm talking about yet. I'll show you a picture that will crystallize this. Okay, so P, we call this length, this segment right here, to a line. It's kind of a little auxiliary segment. Keep in mind the green line is actually the thing we care about, the thing in the end that we want an equation for. But just for the sake of discussion, we have this auxiliary segment that we draw from the origin perpendicularly to the line. And normal, by the way, is just one more. We have like 3 words in math and physics for perpendicular. One of them is perpendicular. One of them is normal, and another one is another one that we'll talk about later. Okay, but we have a couple words for an important idea. That's okay. We do that a lot in life. So we just mean the line perpendicular. Just traditionally we call it the normal line. You might have heard the word normal if you're in physics class too. Talk about the normal force or something, whatever. Good. So let's just acknowledge that those things do uniquely define the line. If I give you P, the length of that segment, that is the kind of the distance away you are from the origin. That's what P kind of quantifies. And the angle at which you are from the origin. Do you see how those things uniquely define the line? For example, if I told you your line is 5 units away from the origin, that is P is 5, and phi is 30 degrees or something like that. Would that uniquely give you instructions on how to draw the line I'm thinking of? I think so. That would be turn 30 degrees from the positive x-axis, say this is the positive x-axis, and then march 5 units out, and then draw your line, right? And then just spread your arms. There you go, right? Does that make sense? Like there's no other line I could be talking about if I say that. And furthermore, every line that you can think of, we can define in those terms as well, can't we? Including vertical lines too, right? Is it cool? You like that? And this is the first time we've thought about this maybe. So just like if I hand you m and b, you know how to find the equation of a line. If I hand you p and phi, we should be able to come up with the equation of a line in this case too, which is now what we're about to do. If I give you those two things, can you come up with the equation of the line? Let's work on it. My next question is, what are the coordinates of this point that I've just highlighted here, where the normal hits the line? Now, I've also dropped a perpendicular in a dashed line here, and I'd like to think about what the coordinates of that point are, which, remember the definition is of the x and y coordinate, right? The x coordinate is simply our name for the distance that your point is away from the y-axis, and the y-coordinate is just the distance your point is away from the x-axis, isn't it? They're just distances. So can you tell me what the coordinates are of this point? That is, what's this distance? And what's this distance? Take a second and talk to your neighbor quickly. We'll come back together in 20 seconds. See if you can figure out what those are. If you keep in mind the hypotenuse is p, right? If you want to think about that. We got a little right triangle. Have you established it in your mind? All right. So what's the I guess the short distance in this picture? This guy down here, the horizontal distance. What's that one? That's p times cosine phi. Do you agree? That follows from the realization that cosine phi is x over p. Yes? So it follows that x is equal to p cosine phi. And similarly, the vertical segment is named y, which is what? The sine phi, there they are, p cosine phi times, comma, p sine phi. Not actually a huge surprise. I think we've gone through that thought process in our lives before. It's certainly not the last time we'll think about this idea. You could think about it. It's the coordinates of a point on a circle of radius p, isn't it? The unit circle, it is just cosine, comma, sine. You're right. But if it's a circle of radius p, then it's bigger. Yeah. So again, the cosine of this angle, that is, the cosine of this angle right here is, do you agree, is this value here called x divided by p? Agree? So does it follow that x is equal to p cosine phi if you just multiply? Yes? And then this follows. X is equal to p cosine phi. Wait. What about the slope of the blue segment, the normal? Next question. Figure it out. The slope is just prize over run. You say kind of informally. Here that means y over x, right, of course. Or that, that over that, right? The p's cancel out. You could even write that, if you like, as tangent phi, if you like. I heard some people say. You should stop to appreciate the fact you probably never thought about this, but the angle that a line makes with the positive x-axis is tangent, the slope of that line is the tangent of that angle, right? Maybe you've never thought about the fact that the tangent of an angle gives the slope of a line, but now you have. Okay. What about, that's actually not the line we care about though, is it? The line we care about is the green line. Can you help me out with the actual line of interest that we're actually caring about today? What's the slope of that? If in fact they're perpendicular, then it should be, say it again, Jeffrey? Yeah, negative cos over sine. Yeah. Or if you want to say negative cotangent, you can. There's a reason I'm leaving it that way, though. You'll see in a second. But it's certainly not wrong to write negative cotangent phi. Negative reciprocal, yeah. That's why you took algebra 1 or algebra 2 or whatever before this. Things you should maybe know. Isn't knowledge great? Are you seeing where this is headed? We now have a point on the line and a slope of our line. Yeah. I think you know how to find the equation of a line if you know the point of one point on the line and the slope of the line. Yeah, which form would you maybe use? Maybe point slope form, if you remember it. Do you remember point slope? That's my next question. Do you remember point slope form? 10 imaginary bonus points if you can remind me. Now, some of you might have trouble remembering it. Okay, I heard some good mumbles out there. That was good, excellent, good job. Now it's interesting to me that some of you do have trouble remembering. Let me help you remember it in a way that you'll never forget it. Okay, you ready? Don't you love this as your favorite? It's probably your favorite form of the equation of a parabola. Am I right? Am I right that that's probably like your favorite form of the equation of a parabola, just because of what all it reveals? We might have a debate about that actually, but a lot of people I think like that. You're very used to that. In fact, for almost any function, you like that, don't you? A times x of x minus h plus k, don't you? So what is this then? Isn't that just a line? That is called point slope form for a line. Or I know you probably normally write it this way, but isn't it the same thing though? It's really, point slope form is the reason that it becomes very quickly, I think you'll see, especially as we move into calculus, it'll become, I think, everybody's favorite form of the equation of a line. You might not feel that way so strongly now, but if you love this for the quadratic, why don't you love this for a line? You should, okay? It's just the transformation form of a line, right? Move to a given point, right? And we're calling, instead of A, we're calling it M, but same deal. Okay. All right, with that aside, let's move on. What were we going to do? Oh yeah, that's right. We know the slope, and we know the coordinates of the point, so let's plug those in where they belong, and let's do some algebra here. Let's see where we go with this. I'm going to start by multiplying through by sine. If you like it, I'm multiplying through by sine, just because I don't like fractions. And then I'm going to multiply out the right side, just because. And then I'm going to move everything over to the left side, just for fun. And now it's time to start noticing some things, if you haven't already started noticing things. I was just kind of cleaning things up algebraically. Do you see anything interesting happening yet? Do you see anything interesting happening yet? Yeah, so we have actually a pretty tidy little form for this equation in terms of p and phi, right? In the box now, finally, is what we call normal form. We don't have to derive it every time, okay? I just thought, as usual, I like to show you how these things come out, okay? But this is why this is the equation in normal form. So in the end, you don't need to go through this whole process every time. If I tell you that we have a line where p is 5, like we were talking about earlier, and phi is 30 degrees, say, well then it's just this. Y sine of 30 degrees plus x cosine of 30 degrees minus 5, if that's the distance away from the origin that you want it to have, equals 0. Pretty nice, right? Don't tell your friends at Algebra 1. They can't handle it. I told you already, they can't handle it. Don't overwhelm them. Their fragile little minds aren't ready. But interesting, right? We have another form of the equation line. Log that in your linear equations area of your mind. Okay. I put it up here. If you still need the derivation though, or something. It's cool. I mean, that's good. I mean, the sense-making part of math is the part that we care about most. So go ahead. Make sure you know where it comes from. I like it. I won't really ask you to rederive it again in your life, but it is the part that makes what we do today work. I mean, now I mean, really, we want to just play around with this now and see what we can do. Can we get lines that we know and love into this form? Can we get Can we graph lines in this form? Can we do all the things we normally like to do with lines with this new equation? We love lines. Lines are so great. I love lines. Okay. So there it is again. I just copied the actual result here. This is our form that we'll keep using of normal form. All right, here's an equation in standard form. How would you convert it from standard form into normal form if you saw it in the wild? Like, how would you do that? Like, I want my equation to be actually in normal form, I hear you say. Well, some of the machinery from yesterday might help. Crystal, you already have like a way in on this? I'm going to be so impressed.
Okay, so we already, so ax plus bx plus...
by, sorry.
Oh, yeah, I was actually confused for a second. Okay, clear stuff. So,
Okay.
already, it shares a bunch of the same variables as the other form with y and x, and there's a constant similar to p. So I would say that a equals sine a sine.
I know, I have it backwards up here, don't I? So whatever, but yeah, I hear you. Like, this is one of the constants, and this is the other, kind of?
Yeah.
Yeah.
And c equals p.
Now the only, that's like super, super close. The only issue comes with the following, because you're almost right. You're almost right. You're right. Doesn't this already kind of look like normal form? This is what she's trying to say. I think she's right. Except for this. Like, what if I have the equation 5x plus 7y plus 42 equals 0? But why is that a little bit of a problem to assert that 5 is the cosine of our angle? Because it can't possibly be the cosine of our angle 5, right? So we have a little bit of an issue with those, but that's okay. We can scale this equation down in such a way that this is the cosine and the sine of something in the way that you talked about. And the way to do that is, harkens back to yesterday. We're going to divide through by root a squared plus b squared, okay? And we're going to choose the appropriate sign to make this p be negative, just because that's how it fell out in our derivations, okay? So I don't have a bigger reason than that. Just like how our derivation came out in the algebra. Just came out to be a minus, carry a not a minus sign. So let's, just to make sure we mimic this form in the red box, let's try to do that, right? So once we've done that, we're done. It's in normal form, I guess, right? P is then just sitting there. It's whatever C is, but scaled down, divided by whatever this is, right? That's your P value. Just sitting at the end of the equation, waiting for you to just read it off. And the angle is a little bit tricky, but it's not too bad, right? It's the same exact discussion we had yesterday about D. How do you find D? Remember, we were looking for an angle that had a cosine of this and a sine of that. Same thing here. You'll look for, once you divide through by this, you'll be looking for the angle, phi, that has a cosine of this divided by that and a sine of this divided by that, right? Same, very, very similar in the way we approach that. So that's the trick. Divide through by either positive or negative. Root a squared plus b squared. So we'll do that in a second. I'll give everyone a chance to digest this slide. Please feel free to make a comment or a question. I'll leave this up for here for another 30 seconds. Say it again. Oh, well, I do this? I mean, it's very similar to yesterday, right? Like, is it true that a over root a squared plus b squared is the cosine of some angle? And, excuse me, b, is this really the sine of some angle? A and B aren't. But what is the other side of your, I mean, if you want to picture a triangle, we got A and B, and what's that other side? Isn't it root a squared plus b squared? So this guarantees, then, for this triangle here, I mean, I'm thinking of triangles here just as a utility. We don't have to have triangles. There's no triangle in the problem, really. But, So what's the, if we're talking about this angle here, then the cosine of this angle is a over that, and the sine is this, that over that. Okay. So, and then p, this value here, if we're going to divide through by everything, those two, then we also need to divide c by that. I do see a lot of hands. Allie first.
When you say make a constant positive, so in the equation will still be minus the value?
Yeah, we want it to be like a minus
Okay.
whatever. Yeah. All right. Let's try one. It'll be elucidating to actually try one here. All right. So let's do the easy direction first. Let's actually, I give you p and phi, you write down the equation. It's not too bad. I should just copy and paste into the equation I gave you. What is it? It's x times the cosine of the angle, cosine phi, right? Plus y times the sine of the angle minus p equals 0. And in some senses, we're like kind of done, right? There it is. There's the equation, the line now, if that's the angle. By the way, can you picture this? 330 degrees would be like put us here. Going out 11 units, we get like a line like that, maybe. All right, so that's a picture of this line here. And here's the equation. It does say write it in standard form. What does that mean? I don't know. Cosine 330 is something. Sine of 330 is something. And then if you want it technically in standard form, I don't know. I think you remember back to Algebra 1 with me. I don't know. Don't we have some requirements maybe of not having these be fractions or something? Or, I don't know. So maybe we choose to write it this way. Just cosmetically, it's not that different. But just for fun, we could write that in slope-intercept form too. What would it be? Oops, actually I messed it up already.
Oh, yeah.
Does that look like, I think this is the answer we're looking for in standard form in the box. But does this look like a line with a y-intercept of negative 22 and a slope of root 3? Sure, yeah, let's go with that. Yeah. Yeah, let's do that next. So this is me giving you p and phi. Like I already kind of gave you normal form to start with. But what if I gave you this, is the question. How would you get this stuff? You might divide by 2, right? Ah, perfect. So let's do that now. Let's go the other way. No calculator needed on this one. Here it is. There's an equation of a line. It's definitely something linear. We got something times x plus something times y equals something. So let's try and get this as much as possible into that form that we like. Start maybe by doing that. And then we'll divide through by something, maybe. Right now, this is not the cosine of an angle and the sine of an angle. That's not true. It just isn't. Again, like 5 can't be the sine of an angle. That's just complete nonsense. So what are we going to divide through by here? Yeah, what is the square root of 5 root 3 squared plus 5 squared? We'll do this off to the side here. Yeah, some of you maybe right away know. Does that work? Right? Yeah, it looks like it's just 10. Or maybe you just knew that just because of like 30, 60, 90 triangle ratios or something. Maybe you just knew that was 10. I don't know. So we're going to divide through by 10. Or actually, let's divide through by negative 10. Actually, when we do, we get here. See, this is nice. Now I'm loving it. Yeah? Sorry. All right, we good? Supposedly we're done. Supposedly that's in normal form. Right? Now, it does say not just to put it in normal form, check, but also to say what P is and what phi are, right? We've got to do both of those, okay? So, P is obvious. What's P? We'll actually always report P to be positive. How about? Right? So that'll be 17. This is minus P, so it's minus 17, so P must be 17. And phi is the angle that has a cosine of this and a sine of that. What angle has a cosine of negative root 3 over 2 and a sine of negative a half? So far, so good? Hang in there. We got one more slide to do. We want to divide by the thing that makes this the cosine of something and the sine of something. And I tried to explain briefly to these guys in the back why that happens here on the other slide. That does guarantee that you do have the cosine and the sine of an angle. You can see, even if you don't believe all of our math, that it does work. You do get something that is the proper cosine and sine of a single angle we're talking about, 7 pi over 6. Good, so we've done it. We've done all three things we were asked on this crystal.
So we can bring either radians and degrees.
Yeah, again, it's not obvious. It didn't say in the problem, so whatever.
Okay, when you're writing it in normal form, like you can simplify it to the actual value, not having write cosine and the
Right.
angle.
Yeah, exactly. All right, I need to share one more result with you, and that's this powerful idea. This is actually really nice. You're going to like this. So far, you haven't seen a lot of utility in this, but this is one place where this really shines, finding the distance from a point to a line. So this, again, is our last slide. But notice that this problem down here at the bottom of the slide is going to be a problem that now for one student would just be like, even though it's easy to ask this question, okay, now for one student wouldn't even know where to start with that, right? Like, that's an interesting question, as easy as it sounds. Do you understand what I'm asking? Like, here's a point, here's a line, what's the distance from the point to the line? Easy to ask, but a little bit hard to answer unless you have some angles and trig analysis on it. Well, it turns out that normal form just lets you do this right away. Let me start by getting this into normal form. I'm going to multiply through by 3 too, just for fun. Getting this into normal form is good. Let's see this. Negative 2x plus 3y minus 24 equals 0. What am I dividing through by? 4 plus 9, so root 13. And then I'm literally going to plug in negative 1 and 7. If you get 0, what does that tell you? It's a point on the line, which like you knew ahead of time, right? The distance from the point to this line is 1 over root 13. Homework tonight is to do the front and the back of this worksheet, okay? You can just do all the odd problems, though. Did you catch that? Yeah. Which problems do you have to do tonight? Oh, you left this? Yeah, just odds is all you have to do. Just the odd problems. Did you catch that? Right? Okay. If you want to do them in right hand, just the odds. Where are the extras? Does someone have another one they're hogging? I knew it. Is that all you need? Great. Have a great day, guys.